Okay, we want to quickly look at this because we'll make the video in response of some of our subscribers that have been asking so many questions on this. So I will give you a brief of what we've done, kind of a strategy we use on lead and zinc exploration somewhere in Swat states, Nigeria. So this is just a quick one. I'll show you some of the strategy, and definitely this will answer most of your question. I am NC Gideon. Always try to share our videos, subscribe, so that I'll be able to bring you more of this. Then we'll run. Understand that first of all, you need to make sure that you have the mining rights as a compliance basics that it's actually required. The consent acquired uh, before you go into any exploration that the community, also development agreement need to be reached, or you have a kind of an understanding. Also, your exploration licenses. In this case, we actually acquired the SSML and SSML2 in this particular location. And if you look at the most prolific locations for lead and zinc production in Nigeria, all are within the middle Benue Trough, the lower Benue Trough. So when it comes to Plateau State, you talk about the Zurich, the Wasa area, talk about Nasarawa State, talk about the the Away area. Then when you talk about the Lower Benue Trough, you talk about the Abakaliki area. So this geology briefly describes the major prolific locations where they actually localized, within the shale groups of Ezak and Asu River Group. This is the major host rock for lead zinc mineralization within this country. Okay, this is the exploration strategy we've actually deployed, and is giving this strategy that actually giving us some interesting results so far. It's very interesting to understand how to use the number one, the aeromagnetic and geometric data processing, because the mineral were of interest here, all within this lower Benue Trough or middle Benue Trough are structurally controlled. And because of that, you need first of all to understand the original structures and auxiliary structures or secondary structures. Then you can actually go on the ground definitely to do some geology and float mapping and actually understand the outcropping patterns. Then you'll be able to tie the knots and understand the process. Then you can carry out some other ground truthing kind of work using an inductive magnetic scanning, AVR, or sometimes you can actually use some other, VLF, a very quick ones, just to understand the structure that you actually interpreted. You can also deploy some ground magnetics, but if they are the way that if you've done your processing very good enough, you might actually not need that. You might go straight to the soil sampling. Now, soil sampling are in different patterns. You can start soil sampling in different stages. You can actually put them in grid, or you can put them in grid in such a way that they are detailed. So if the soil sampling is well done, it can actually find give you an interesting soil anomaly, which we've done in some locations, and we're able to find out this. Then if you don't want, you can actually do it in such a way that you can do 200-meter grid, then it come down to 100-meter, possibly come down to 50-meter grid. So this is has been always been a good one. Soil sampling, but the easiest way to test this is that you need to understand that you have to have your hands on a very good XRF system, portable XRF. This would be a very quick one to do. Then the another one is after you've got these anomalies and all that, you can profile using a two-dimensional ART or IP. But you need to understand the geology where you are working, what is actually hosting. If it's shale is easily delineated. But if it's sandstone, you have a problem. You might try to combine other geophysical methods such as gravity, because of the density nature of zinc and lead. But if not, if it's shale and the shale thickness is not is very much, most of the time, if you're not careful, it can actually mask what you're looking for if the lead zinc is not appearing in a very significant form. Then the next one we did was just to target analysis, and we were able to do some pitting and trenching. Some location it's easier to do pitting, some location it's easier to do trenching. But trenching most of the time is very okay if you're able to go across your anomalies at least to some depth of 8 meters. at the first step. Then that will be easier for you to detect if the mineralization you are actually targeting are actually there. Yeah, there are some signs along the wall, and also you can also log the walls of your trenches. So this is also very important. Then finally, we made in forensics and able to make some resource determination based on this. If you can see, this is what we've done, and this is where we actually, this is just one. We can't bring in all the whole data here, but this is just what I would say that I've shown an interesting anomaly here. This is an analytical signal map. This is the area that I've shown an interesting structures in the north-south direction, and also this is, this is the major source structures here. The northeast structures, that is, you can see actually well detected, and this and that. So here we've been able to fix on this. So we try to do this phase by phase in able to come out with an interesting result. There you can see here we're able to divide them into zones, so it's easier for us now to map in terms of um, soil sampling, in terms of profiling and other methods. After the first one, we're able to eliminate some other lot of other locations. You can see the entire region, but now we've been able to mark out some zones and area of targets. So we now zoom in on this particular location. Now, based on those particular location, we're able to carry out this some XRF soil samples. Along, you can see we got up to 3,480 ppm in some location, and also 2,350 ppm in some location based on zinc. So some samples actually contain the elevated number of elements. Especially this is the first sampling we did, not actually well detailed, but at some point we are looking at there should be targets. Enough to that, we use that target to say, okay, we are close to what we are looking for. Seeing that, so we're able to conduct some to the our resistivity in those locations, and they are the very interesting anomaly striking in the north side direction, and they're very actually continuous. You can see them here, and also here where we try to model it in a block form. We try to see where are the high credibility is actually concentrating. So found out that they're actually in the north-south direction. So this is the 2D IP section, and this is also the resistivity section. But if you look at this 3D here, you can see that there is a very clear continuity of anomalies of credibility at the same depth, at the same look, kind of continues from the north to south, and that is actually placed where we are actually looking for these veins. Then next thing was after that we started trenching. So you can see inside the trench, you can see the host rock actually cutting across it, and we're able to intercept some interesting samples within this when we started pitting. You know, so when we got this, we had to follow it down. To be able to intercept it at about 10 meters. It's between 8 to 10 meters. From 8 meters, we start seeing some sign of interesting mineralization. And this was actually also tested, and we were able to get about 66% of lead in it and 0.83 percent of zinc in this particular location. So I would have brought this before, but this then is coming late here. The inductive scanning was actually conducted here also. That was another method we used before we were able to deploy the IP. The inductive scanning also coincides with the structure that were actually interpreted initially, and based on that, we collected some soil sampling. So here, the lead signal actually show almost 1.3 kilometers in the north south, and that is actually where the IP were carried out. The IP then actually carried out here, but actually carried out here, and that actually showed it. So this is also another parallel vein. We think that is possible in this direction. So that is what we've seen here, and based on that, we are suspecting that a minimum of about 1.6 million tons will be on this particular region. Based on these parameters we actually use here. Typical width here 1.5, the average ore grade 55, depth of minor occurrence is 10, and depth of economic occurrence is 20. Then minimum thickness of ore occurrence is 90. Then specific gravity is about 11. Then this would have that. This is pending when the drilling is actually done on this particular region. So this is just possible and speculative resources we we actually looking at this. That leads to aid us in making some some projection about cash flow. So that is actually a brief of what we've done and the strategy we used on this lead zinc mineralization. Thank you, and I hope you have a nice day. You can always send us a question on our comments, share our videos. Next time.